Hello, everyone, and welcome to the PieCast for February 16th, 2021. I always like to give it a couple minutes for folks to start filtering in our viewers. Today, as always, I am Avram Pilch, Tom's Hardware Editor-in-Chief, joined by Associate Editor Les Pounder and our very special guest for this week, Graham Sanderson. Hi, Graham. Thank you so much for joining us.
Yeah, nice to be here.
So, Graham, do you work for Raspberry Pi Foundation?
Sort of. I'm actually a contractor, but I'm just because I'm US based. But I for the last year I've worked pretty much consistently on with Raspberry Pi, in fact, with trading Raspberry Pi Trading Limited.
So can you tell us what you do for Raspberry Pi trading?
I guess you'd call me right now. You'd call me the SDK lead for Pico. So over the course of the last year, I've been working on the software. But a few years back, I guess it was 2018, Eben contacted me and said, "Yeah, we're building this chip, and we want it to be like the most, it needs to be cycle accurate down to the wire. You don't want to have to put in 20% of margin, and we want it to be really high performance. Would you like to just go kick the tires?" And so I was in it. I was working on it my spare time for the last few years and writing a lot of these demos. And it was really great, actually, because I got to work on the hardware as it was being built and make suggestions, and some of my software is made into the chip. Not least, and of course, the boot ROM code is mine as well, which is kind of scary when it's burned into the chip.
Wow, that's fantastic. Yeah. So when you say you worked on the SDK, do you mean you've worked on the MicroPython port or the C port or something else?
The actual development of the SDK. As in, I'm not the only one, but obviously people at Raspberry Pi too. But you could call me the lead, and then I helped with the porting of MicroPython. But most of everything else is built on top of the C SDK. So the C and C+ SDK is kind of the lower level software, which sort of takes the place of an operating system on a larger machine.
Wow, fantastic! Well, we've been having a lot of fun playing with the Pico for not as long as you have, but for several weeks. My son and I have been playing with them a lot. Later, I'll show the status of our latest project. Perhaps you have some advice for folks who are trying to do what we're trying to do, which is we're trying to make a Nintendo Switch controller out of our Pico.
Oh, absolutely, yeah. No, I think you could do that with MicroPython or CircuitPython. I think there's some examples out there for making a HID.
Yeah, I will show folks later that we've gotten really far in terms of getting it as an HID device, but getting it to be turned into one that's recognized by the Switch as a Switch controller is apparently another level. Like it's perfectly recognized by Windows as a controller, but for the Switch, I think you have to do something special. But it's just been a great fun, and there's so much we can do with it, and it's so exciting to see what people have done with it, including you. You've managed to create an emulator, correct?
I've actually created two so far. I have a BBC Micro and BBC Master 128 emulator, and that was kind of key. I mean, I kept this a secret for a while until it was done, just to surprise the folks at Raspberry Pi. But obviously, I grew up in the 1980s, writing games for the BBC Micro in my bedroom, and Eben, it famously has the same history, and so it was definitely a nice to have to get a BBC Micro emulation. But before I did that, actually, I did a ZX Spectrum Emulator, which was a little bit less technically challenging in terms of just how wacky the beeb is, and it's actually quite hard. There's a lot of work to be done to emulate BBC Micro. So, but I think it's super exciting. I think there'll be a lot of the RP2040 is capable of emulating a lot of platforms. I know there's an NES one out there already, and I believe there's a I've seen Sonic the Hedgehog scrolling by somewhere, and to your Nintendo Switch thing too. It's the perfect device to make either. I've seen people making games cartridges with it, and it's I like to think of it as the universal digital glue. You can pretty much connect anything to anything and emulate. Whether it's a game, a retro computer, or whether it's a device which is part of a game system. It'll be really cool. I think probably one day there'll be people making actual emulating 6502s and Z80 chips. That you could replace one with the Pico.
That's fantastic. So can you show us one of these emulators?
Sure. I'm gonna turn. Hopefully, I don't get too much echo. I'll make it. Oh, I've kind of disappeared. Can you hear me? Can you hear that?
Yep.
Okay, that's good. So, can you shrink me a little? Everything's off the top of the screen.
I think you have to shrink yourself.
Okay, well, I'll tell you what. Let me just move it then. See if I can.
That's better. We can see the acorn.
Oh, we had it there for a second.
Yeah, I'm just going to make it a little smaller. There we go.
Then go.
There you go.
A little more of me.
There we go.
This is my first time streaming, so it's quite exciting. All right. So yeah, I actually just hit. I just hit reset on the device, and so I'll show you that in a sec. But I can go ahead and this is a fully functional BBC Micro.
This is bringing back some memories. Yeah.
And so I can do that. I can do all the usual, all the usual rubbish. But let's see. I played some of these demos. This is actually a master. This is being emulated. So this is good. Actually, this is written by Eben Upton, or by Eben, and so it has a slightly weird font because he cheated on his font. But I can show you. Let me show like one of the demos that I had. Let's see. Actually, well, let's play. Should we play Exile? That's a good game from the past. And so hopefully you can hear. We'll get some disk noise. And I didn't write this emulator from scratch. It's actually based on the VM emulator, but bearing in mind that this is a 128K BBC Master 128, we've only got 256K of RAM. And so that's pretty fun. But I can actually go ahead and show you the ZX81 emulator, because that's actually quite fun too. We can talk while I'm doing that.
Yeah. So how did you get this to work? Is it a custom firmware UF2 that you flashed to the Pico?
Yes. So the program is written in C and assembly against the Pico SDK, and so it is just a UF2 that you can download to your device. I'm going to open source it soon. I mean, so that people can build it themselves. The games are obviously built into the Flash image, and so they have to build it themselves right now to incorporate games. Except I think Evan says I can have 2048 out of the box. But this one's quite fun. Like, so this is a good old Spectrum, but nothing would be complete without Blinky. And so I can actually, I think you can see. So I can, this is a program written in ZX Spectrum Basic. I can pick a pin number, and then I can pick a delay. And you can see there that I have the Spectrum program blinking the pin on my Pico. Oh, by the way, this is a Pico board mounted on what is effectively it has a resistor, it has a VGA connector on one end, and then it has either I2S or PWM audio on the other end. And this board is described inside in one of our books, hardware design, but you can make it yourself using a breadboard, or alternatively, Pimeroni's coming out with I think it's called the Pico demo board, which will allow you to play these games. So yeah, you'll be able to play both the Spectrum and the BBC emulator yourself on your Pico.
Yes, I have. Pimeroni just came out with that. It was on sale briefly on Friday, and I immediately ordered one. Les has one that he can show in a minute, but yeah, it's pretty impressive that you're able to drive the display using that. So what did you have to do to get it to actually use VGA out?
Okay, so early on, video is a great way to test that the chip was actually doing the right things and was working correctly. And so to drive the video, basically we use the PIO, or I use the PIO, and one state machine, which is a little off-chip, hardware level, tiny little processors, and one of them just generates the timing signals. So that's like the horizontal sync and the vertical sync, which create the picture, and then another state machine is drawing each scan line out, just sending RGB data. So it's actually sending the red, green, and blue on 15 pins, and then it's just a set of resistors which turn that into an analog signal, which is all that VGA is. So VGA is just red, green, blue, and V-Sync and H-Sync is all you need. And so we actually have code in. We have the Pico SDK. There's also called Pico Extras, which is code that we haven't just got around to. It's not up to the polish level that we want it for the SDK, but it's totally usable. And so there's demos out there which show how to use it. And I expect that other people will do the same. I've actually noticed that a lot of people on that I see online are actually writing it from scratch themselves as a learning exercise. It is a great learning exercise, to really understand how things work. But if you don't want to do that, you can use our libraries. And so in terms of getting the emulators to run, basically what I did was I took other open source emulators, and then I massively, people tend to not think too much about having a 400K lookup table here and there, which really doesn't work when you've only got 256K of RAM. So it's basically an exercise in just really optimizing the code and changing the way things work to be super efficient. And so, but the real benefit, as much as I was writing these for fun, it's also a good way to check that there aren't any gotchas in the chip, because it's very easy to see if one pixel is off, when you're looking at a screen, or if the picture is shimmering, or if it suddenly goes black, or whatever. So it's both fun, but also useful. And then the audio again. Actually, the funny thing is the ZX Spectrum the audio, all I do is to set the pin to high or low, exactly as the real Spectrum does at the right time. So that's quite fun. Yeah, you'd have seen that the noise that comes out when the tape is loading is the direct result of that. So,
Cool.
but yes, it's I think there will be a lot of people doing little things like this, especially with small form factor devices. But it's also just a way to make sure and demonstrate that we get a really high level of deterministic performance out of the chip. Maybe it's not the most useful thing, but it sure is fun, is the way I look at it.
So can one do VGA out in MicroPython, or is it only C at this point?
It's only C at this point, but to add frame buffer support to MicroPython shouldn't actually take too long. If it's kind of weird, because bearing in mind we only have 264K of RAM and no actual video circuitry. a frame buffer for a 640 480 display is bigger than the amount of RAM we have, and so we do interesting stuff. Basically, we're just generating the signal on the fly with the PIOs, so we don't actually even need a frame buffer. But obviously, for MicroPython or CircuitPython, you would just want to use a smaller frame buffer, and we can add that quite simply. And so hopefully within the next few weeks, I could add something like that once people start getting boards in their hands, so that they can do that. It's very similar to I don't know if you saw Luke Wren's DVI output from Python. It would be a similar idea to that. But yes, you would be able to do it from Python. You can't today.
Fantastic. So we've seen somebody do it with DVI. Is it feasible to do it with HDMI, or is that too complicated for this chip?
That's a little out of. I'm not exactly sure of the ins and outs of that. DVI and HDMI, I believe, are very similar. HDMI is either trademarked or has some specific requirements. You can't call yourself HDMI. I think Luke calls his not HDMI for that reason.
Got it.
But it is effectively the same thing, as in you can plug the DVI into your TV via an HDMI cable and it works. So yes, the video support we have, we're intending to sort of extend it to allow the same kind of output with little LCD panels. You'll see actually if I on my infamous perhaps desk, I have oops.
Yes, Graham, we've seen your desk. We've seen the Twitter pictures.
Your desk is quite organized compared to mine, so no judgments.
Oh yeah, I was just going to show. I have a couple of these. I have a couple of these panels which do work with it. It's kind of fun. But the intention is to have DSI and DVI and DPI and DBI. There's a lot of them. There's a lot of D something I's, which makes sense. But yeah, and as I say, it's a lot of fun, and I fully expect. I'm really hoping that someone else will make a Commodore 64 emulator, because it should be about the same complexity as the BBC Micro, and I do think we should have a full list. Wow,
fantastic! That is just so impressive. So, are you actively working on the MicroPython or C SDKs right now?
Yes, I'm working on the C SDK. So, we've done a lot of little bug fix and minor feature request changes, partly to support other languages. We have Rust, and I guess Rust is the main other language other than Python at the moment. But I don't know if you saw, there's a mini Linux or Unix-like UF2 out there as of yesterday, which sounds really cool. I haven't had a chance to play with it. But then a lot of the stuff in Pico Extras, so the audio libraries and the video libraries and the SD card stuff, I'll be working to bring that into the main SDK and get some better. I mean, we have some examples, but they're not very well commented. So stuff that people can play with, and then yes, it does make sense to. I know CircuitPython is has a lot of the has its own audio stuff, but we also have support for doing PWM with like fancy ultra high frequencies and the sort of stuff that's I believe in the newer Pis for their PWM in terms of producing a slightly better sounding PWM output, although without having to buy an I2S DAC. So it actually sounds pretty good.
Do you think MicroPython for Pico will get HID support like CircuitPython has? As I say, it's open source. Anyone can add it. I don't see why not. I think that's MicroPython is fully upstreamed now, so we're not actively working on it. Although we can obviously commit code, we're just quite resource constrained at the moment. If enough people make noise, I'm sure we'll help. Great. So we have a question from Russell Davis, who asks, how generic is the 6502/Z80 cores, or are they tied very closely to the MU'd hardware? Is CPU code easy to rip out and drop into other emulators that have weirder hardware?
They're actually not. They're not tied to the hardware hardly at all. So yeah, the code could be ripped out. It's not 100% clean split, but it wouldn't be too hard. So yeah, it could. You could definitely use the 6502 for your Commodore 64. I hope Commodore 64 was 6502. I think it was. I never had one.
That's great. So Les, you've been using a whole bunch of Pico accessory boards. What have you been working with?
Well, just recently I've been messing around with lots of Pimoroni boards. So we've got the ones that we know and love so far. So we've got the Pico Explorer here, which I'm messing around for a review as we speak. And it's a good little way to play around with the Pico and explore how to do electronics in a safe environment. I've been playing around with other bits and pieces. I've got a whole box full of stuff. But the main thing I've been playing around with is not the Pico, but it has the same chip. So I'm going to switch to my overhead camera. And this is the tiny 2040. This is from Pimoroni. And it's currently the smallest Pico-alike board you can find. It's a little bit more money. It's about £9 in UK money. So that's about $15 to $20 in US. But you've got a distilled version of a Pico in a small package. So as you can probably tell, we haven't got as many GPIO pins as a full-size Pico. Put that just next to it there so you can see. But what we've got is the bare minimum that we need. So we have 8 digital pins on the right-hand side. We also have I2C and we have SPI. Only one I2C, one SPI channel. We can't have multiples, unfortunately. We've got 4 ADC pins. So we can have 4 analog devices connected or 2 joysticks for the X and Y axes.
Yeah, one thing I'm wondering about that, and maybe Graham has some insight into this as well, is why is that possible on a third-party board, but not on the first-party Pico?
Which particular part? Sorry.
I mean, having four ADC pins, because there's only 3 on the Pico.
Yeah, one of the ADC pins on the Pico is used. It's slightly out of my wheelhouse, but it's used to monitor the core temperature, I believe, or voltage level for the power supply. So it is used for some features. Sorry, I'm not super. As you've seen from my desk, I'm not super good with the electrical side of things. I'm more of a software guy. That's why the reason my desk got that way is I'm afraid to take anything apart once it works.
Yeah, I hear you. That's why that's how you end up buying a lot of Picos and Raspberry Pis, right? Like that's what people ask. Like, now I have something like 20-something Raspberry Pis, and I had 4 Picos, and it wasn't enough. Because once you have it in a project, it's like, am I going to take this out when it was working and mess with the wires? So, yeah. So I find it impressive that Pimoroni has managed to get you that 4th ADC pin, which allows you, if you were building a controller, which I guess is on my mind, allows you to do two analog sticks.
Yeah, no, I love this little chip, and I'm waiting to get mine one myself. And that's one of the beauties. It's super exciting not only to see what people do with the software, but with what people do with the chip itself. And the Pico itself is designed with very specific design goals in mind and price. But once you unconstrain yourself a little, you can. And Pimoroni and others have done a fantastic job of building some really interesting initial boards with it.
So I'm sorry, Les, you were talking about your setup here.
Okay. So yeah, it is a smaller Pico, really. It's an RP2040, but we have 4 times the storage capacity on here. We've got 8 megabytes for flash versus 2 megabytes on the Pico. So we have lots more space to store stuff, and I took advantage of that. I've installed CircuitPython on this board, and I've got it controlling my scenes in OBS. So right now it's a human interface device, a HID, which thinks it's a keyboard. And I've got 3 scenes set up in OBS. The main one, which is me. Hello. The overhead camera, which is, here we go, that's live. And a third one, which was to play a video of Ash, who's the presenter of the show. Here we go. There she is, waving. And it's all just control over the buttons. And that was exceptionally easy to write in CircuitPython. It's only about 25 lines, and most of that is print statements to help me debug what's going on. But I also learned something really interesting about the Tiny 2040, talking to Pimeroni the other day. There's 2 buttons on here. One is boot select to boot in to flash USB firmware to it, so UF2 files. The second button is like a user button. Sorry, I got that wrong way around. I'll start that again in case anyone's listening to me. Russell will be listening. Hi, Russell. They've got a reset button here, which isn't present on the Pico. It's only got one button there. As you can see, just one there, unless you buy Captain Resetti from Pimeroni, that add-on board. So we have a reset switch on here to just reset the Pico whenever we need to. We've also got the boot cell button. Now, normally that's used for UF2 to set it into a firmware mode, so you can put new firmware on. So you can put C on or MicroPython or CircuitPython. It's also a user configurable button, so I can use that in my code to do something. So I can press that button and have it become a USB keyboard. So the other night I was messing around on my laptop, and I had it, when I press the button, it would print a statement in the bash terminal just to run a command really simply. And it's all perfectly safe, and it's all easy to do. So I really do like this Tiny 2040. It works really well. It just believes it's a Raspberry Pi Pico. So the same firmware, so the same MicroPython, C, CircuitPython will work, but I've got a much smaller package. The extra ADC is really nice. And, well, I've got so much to do with this board. It's brilliant.
Great. That is fantastic. So Ash couldn't be here today, but she wanted to share with everybody the project that she's working on. So I'm going to show a video that she shot of something really cool she's working on for the Pico.
Hey, thank you Avram and Les for sharing my segment today. I've got Pico fever, and I think you're going to like what I have to share today. So I'm out today on a small health-related issue, but I should be back next Tuesday. But for right now, I want to show you guys what I've been up to. So we share some crazy cool projects from the maker community all the time, but I've always been fascinated by the makers who create their own PCBs. So I downloaded KiCad, an open source application used to develop circuit boards, things like that, and I took a stab at creating my own board for the Pico. Here's a quick look at the board, and for those of you who are listening, this is a 2" by 2.5" board with room for the Pico to mount in the center, with 2 8x3 pin connectors, one on each side of the Pico. And the idea was to create a controller board that simplifies the setup process for things like servo motors. The Pico can use up to 16 pulse width modulation channels, which is how many servo motors this board can support. It makes it possible to power your Pico and servos with one battery. This is just a prototype. I need to order one of these and give a proper test before it's ready, but once it is, I'll be sure to post the design online for anyone to use and modify. So what do you guys think? If you were to create a custom PCB for the Pico, what would you want it to do?
Wow. Well, I'll start with you, Graham. If you were creating a custom PCB, which I'm sure you could, what would you want it to do?
I'd want it to work. which would potentially be a trouble. As I say, my hardware skills are pretty small, but yeah, I think I the little project I have in the back of my mind is an ugly Christmas sweater, completely completely a wearable display from top to bottom in LED WS2812 LEDs, and so I figure I might want to build a PCB for that. But in general, just the ability to interface. So actually, one of the things I've been playing with is the SPDIF, like digital audio links, and the RP2040 is fast enough to deal with that, but I need to for it to work, I really need to get down and have a PCB which has one of those optical connectors on it. So, you know, I think it's amazing to me, just because I haven't really been in this space, how easy it is now to make a PCB and you know, get it made up for you. And I guess I could do it as long as they solder the components for me, because otherwise it definitely
Yeah.
They can do that now. You can get a full prototyping service. It takes a little longer and a little bit more money, but they can do it.
Yeah. No. Although actually, no. As I say, you know, I have a weird, well, not a weird history, but I started programming, you know, way back in the day, and I've grown up. Well, I've seen the inside of everything, and you know, the last 20 years I've been in, you know, enterprise software and distributed systems, and so it's super exciting to come back to this level of machine with all the experience I have and be back kind of where I started in my bedroom 35, 40, 30, 36, 7 years ago. It's kind of scary. And so, yeah, I'm actually learning this stuff, you know, actually having the Picos now, you know, I'm actually going to start trying to build some stuff myself. And it's great to have all these resources online to help, because literally I have exactly zero skill when it comes to electrical circuits.
Great. What about you, Les? If you could build your own Pico board, what would you do?
I'm in two minds. The instant thing I want to say is build a robot, because I love building robots. But just thinking back to what this board can do, so we can emulate BBC micros, we can emulate ZX Spectrums, and Graham's mentioned the Commodore 64. That's the computer I grew up with. That's the machine I was messing around with, and I'd love to see some form of C64 emulation. So some little case, a C64 case with a Pico inside, doing all the work to make it as authentic as possible, and just loading games into it and reminiscing. That would be fantastic.
Yeah, no, it does look pretty awesome when you just have the Pico on its board on the desk, and you've got the keyboard plugged in the front and the monitor plugged in the back, and you're able to play the games. And so, yeah, definitely making a sensible sized PCB, which really really shows that. And then some little audio stuff. You know, we have a USB sound card app in our extras, and so things like that. You know, I need to actually, you know, I need to move up from blinking LEDs in terms of my hardware capabilities, and then I'll probably come up with some more interesting PCB designs.
I would love to make a controller or a full keyboard. I mean, we know that Pimoroni is coming out with a new, I think Les has one there, a new version of the Keybow, which has the RP2040 built in. I'd love to see someone do that with an entire full keyboard or 10 keyless keyboard, and I'd love to be able to make a game controller board that just, you know, had the buttons on it and everything, because I think it'd be really, really cool. It's just great how you can turn to an HID device. That's my favorite Pico feature so far. But
noted for the MicroPython.
Yeah, I'm using it with CircuitPython now. It's great. I'm just having some issues with it, which you know, there's not a lot of people who've been able to do it. There is a library called NSGadget out there for the Trinket, for the Adafruit Trinket, that will allow you to do it. So I've been looking at that. But I just wanted to show folks how easy it is using CircuitPython, which is an easy thing to flash onto your Pico. To create a controller that works at least in Windows and probably other platforms, just not yet the Switch. So I'm going to share my screen here. Although before I do, I guess I will show you how my wiring. So it's a little ugly to look at on the breadboard. That's why I need it to custom build PCB. So I have 4 buttons here, and each one of them is plugged into ground and plugged into GPIOs 18, 19, 20, and 21. And I have my analog joystick here plugged into ADC 0 and 1 and into ground and 3.3 volt. And what this will do is, if I share my screen, I'll share the screen up here. What you'll see is, I mean, this is my code, but before I get to the code, I want to show you that it works. So if you've ever wondered how to test something in Windows, if you go to set up USB game controllers, you search for that, you get this little menu here. I've named this Wired Fight Pad Pro for Nintendo Switch because I thought that might help fool the Switch. It doesn't. But anyway, if you go to properties here and there's a little window pops up, you'll actually be able to test all of your stuff. So if I move my joystick around, you can see it moves the axes around it. If I had a second joystick, it would show the Z-axis. And for each button, it makes one of these lights light up. There are 16 possible buttons, and I've assigned these to A, X, Y, and B, which are buttons 3, 4, 1, and 2. At least how other Nintendo stuff shows up, other Nintendo Switch controllers show up. So the code is very simple. This is CircuitPython, so slightly different than regular Python in terms of the libraries. I import the time, the board, these things from Digital I/O, and the USB HID library. And what I do is first I assign the X and Y axis of the joystick to these analog pins 27 and 26. I let it sleep for a second because if you don't, it might be too quick when it's first starting. I assigned, this is kind of a lazy way, I should have done this as kind of a list, but I assigned buttons A, B, X, and Y to different pins, creating each as a pull-up with input direction. And I've created a dictionary here with the button letters and their corresponding button numbers. And then I have a simple while true loop, and it sees if the button has, the way that this works is if the button returns false for its value, that means it's pressed. So again, there's a property, there's a method here for the pad that I created. First I created a pad called MyPad, which is a game pad. And then you can tell it what button number to fire or release. And then you can it reads the X and Y axis value. I found that at least on my joystick, a value of 600 or less was left. And so it shows you what the actual value it's looking for is like negative 127 or positive 127 or 0 in the middle. So it sets those values based on whether you're up or down, and then it moves, and then it sends it to using the move joysticks method of your gamepad, and it checks for that every 0.01 seconds in the loop. So that's just really, really simple and basic. But right now, this works perfectly in Windows and probably on other platforms like Raspberry Pi, but not. But getting Nintendo Switch to do it is a little bit of an extra challenge that I'm working on. But for those who are trying to create a controller, if you're trying to create a controller that works on other platforms, this is really easy to do. Once we figure this out more thoroughly, I'm going to put up a tutorial on how to do it. So it's become my it's become the whale that I'm chasing to try to get Nintendo to recognize it. So I want to thank Graham for coming on our show and showing us this awesome stuff. Thank you so much, Graham. Thank you as always, Les, and to everyone who's tuned in. As always, you can catch us at 2:30 p.m. Eastern, 7:30 p.m. GMT on Tuesdays, and we will see you next week. Bye, everyone.